I think that's going to be too loud, Bird. Okay. I've got two. Okay, so. And then. Okay. Can you all hear me?
Yes, sir.
For some reason, I've got two parts of myself here. I don't know how to get.
I feel you called twice. That's probably why.
Well, I didn't intentionally do that. Somehow it just happened. So I don't know how to get rid of this.
Let's click on the other one. You don't want to hang it up.
Yeah, I'm trying to, but it won't do it.
You could probably kick it with the Zoom permissions.
Maybe. I don't know. Yeah, I don't know. Let's see. Yeah, it's muted, but let me, I don't know how to do this. I think if I, okay, I'm going to leave.
Yeah.
I think that worked. Okay. Yeah, I was afraid it'd take everybody out. All right, well, welcome. So let's see. So we got a good number of folks here, so that's good. So we are recording the meeting. All right, welcome. Welcome to Logic Design. So we have a few things to cover, and so I wanted to kind of go over some things, and then we'll dig into the material just a little bit today. So let me just say, first of all, so this is a little bit of a unique experience for me, although I've taught this course now for over 20 years. And usually something like 80 to 120 students a semester. This is over this last year, I wrote a textbook for this course. And so this will be the first time I'm using that textbook. And it's an online e-text. It's the publisher's Great River Learning. And so that experience in itself was rather interesting. There were a lot of things I didn't, let's see, can you hear me okay? Or is there okay, I don't know, it looks like someone's having problems. Okay, anyway, so the whole process of doing a textbook is really interesting. It's, you do all the work, and the online publisher does a little bit of work, and they get 90% of the revenues, and you get 10. What I've done, I didn't do this for the money. I've assigned all the revenue that I would get from the book to go to UTSA, to the Paul and Phyllis Morton Electrical and Computer Engineering Department Scholarship, which isn't active yet because it doesn't have enough money in it. You have to get about $25,000, and then the scholarship will go active. And I'm putting $5,000 a year from my salary, and then the proceeds from the book, and I might kick in a little more to see if I can get it off the ground sooner. But we're getting there. We probably getting maybe 10,000 or something. So maybe not quite half the way there. So certainly, so my motivation wasn't money, but of course that is the publisher's motivation. And they have there were a number of things they didn't tell me at the beginning that I sort of learned the hard way. So it's been an interesting experience, I will say that. But I have but I've actually learned a lot doing it. I felt like I knew this material pretty well. Well, I think I do, but there were some things I discovered I didn't know all that well when I actually wrote the book. The other thing it allowed me to do was to tailor it to exactly what I think is important, and to get rid of some of the annoyances in the textbook I've been using. I've been using a textbook by Roth and Kinney, and I think this semester they actually put out a slightly improved version called Roth, Kinney, and John, or maybe it's coming out, but it's not a new edition. It's just it's enhanced edition, they call it. And the Roth text is okay. It's fine. I use it for, I started with the 5th edition, then the 6th, and then the 7th. So we're up to now this enhanced 7th. But there are some things in it I don't like, and there's a lot of things that are covered in some detail that I think is not all that helpful and useful for students. And so I've tried to sort of strip out the things I thought were distractions and really focus on what's important. And then I've added some new material at the latter chapters having to do with looking at how you actually develop algorithms. Yeah, you know, how you look at a system and how to break it down into parts and how we think about systems. And then a lot more emphasis on state machine charts, which I think are more powerful tools than the classic way we do that we used to do sequential design. And although that does appear in the Roth text, it's almost it's the next to last chapter, and it's covered in a somewhat of a dismissive way. And I think it's a very powerful tool. Probably should get a lot more emphasis. So that's what I try to do. The Roth text spends a lot of time doing the switching algebra work, which although I think it's important for the student to be familiar with switching algebra, most students struggle with switching algebra. And in the end, we have computer-based tools that help you with most of that. So you really just need to have a level of understanding that allows you to tell when computer-based tools are lying to you, basically. So maybe a little bit of less emphasis on that, although I think it is still important. But we would spend the whole semester to try and get you to kind of the expert level of switching algebra or guru. And I don't know that would be all that helpful, frankly. Okay, so I wanted to take a minute and, most of you I probably haven't met. And I guess for many of you, this will be one of your first electrical and computer engineering courses. There was a little link on Blackboard for you to go in and identify yourself, give a little blurb, and I would encourage you to do that. I was reading those the other day and found lots of interesting things, and some of which will probably help me kind of connect with a few students in particular that had some experience that I was really interested in talking to them about. So feel free to kind of share what your interests are and things like that, and kind of your road to wanting to become an electrical engineer. Many of you already have a fair amount of engineering skills, and you're just kind of honing them and getting your degree. Okay, if you have questions as we go along, feel free to ask. And I'm gonna, so I think what I want to do is talk about the syllabus a little bit, and a little bit about the course organization, and then I'll maybe a little bit about the text. So we'll kind of do a few things here. Let's see. That's good. So we'll put this over here. All right. And all right. So let me start by looking at the syllabus. And let's see. I don't think I pulled that up. So let me do that. So I'll share my screen here, and we'll go over the syllabus. Okay, so let me share my screen. Okay, can you all see this now? It says EE 2513 Logic Design Fall 2021.
Yes.
Yes, sir.
Okay, great. Okay, so there's a lot of, so I used the university provided template. Uh, and so there's a lot of boilerplate stuff in here. So you can scan through it, but I'm just gonna scroll and point out some somewhat important things. There's a lot of COVID related. So here's some contact info. So if you want to get in touch with me, if I'm on campus and I'm in my office, it's the Bioscience and Engineering Building, 1.538. It's in the main electrical and computer engineering office area, kind of in the middle of it. I will have office hours on Mondays, and I will today. And I said noon to 1, but actually I because this class finishes at 11:50. I might not be able to get back to my office by noon and get online. So I made it 12:15. Now I'm home right now, but I'm gonna when I finish this, then I'll have my office hours from home at 12:15, and then I'll at 1 or thereabouts or a little before maybe, then I'll finish that and I'll head on to campus, and I'll be in Digital Systems Design Lab from 2 till at least 3 and maybe later, depending. So some days once we get to where we're actually doing class in person, which I'm really looking forward to, because I would like to actually see you guys, because nobody turns on their camera for some reason. I would encourage you to turn on your cameras. It's fun to see you. But in any event, I'm looking forward to that. And hopefully you guys will too. It's interesting. If you ask a college student, would you rather do your education online or in person? Almost everybody, probably 80% say, oh, much rather do it in person. I hate online. It's really horrible. Well, so students had a choice in this course because we created an online course using the old book and then this in-person course using the new book. And I think there are 39 people signed up for the in-person course and 58 signed up for the online course. So it looks like about 60% of students say one thing, but they'd actually really rather do another. Because it is convenient not to have to get out of bed and drive to class. I get it. But I think your learning is enhanced, and I think you will get a lot more out of lecture when I can see you and you can see me and we're going through it. So anyway, so if you need to get me, my mobile phone, 210-887-7700. Okay, so I don't usually answer calls I don't recognize because I get inundated with various, marketing stuff, prank stuff. I at least once or twice a week, I get called up by somebody who purports to be from Amazon, telling me that they have a concern about a charge for a new iPhone 12 for for $900, and they wanted to know if that was my charge. And what they really want is they want to scam me and see if they can get me to give them some gift cards. It's amazing. Or I get calls for people who want to sell me a warranty for my automobile, or they want to lower my credit card interest rate, or they want to get me out of my timeshare that I never had. I swear it's unbelievable. So, or they want to sell me a walker or some oxygen, which maybe I do need. All right. Well, anyway, so if you want to call me on my cell phone, just send me a text and tell me, can we talk? And then I'll just call you right back. Because I do generally see the text, although sometimes if I'm really busy, I'll miss those, like if I'm lecturing or something. My office phone is 5599, but if I'm in my office, I answer it. But of course, if I'm not in my office, I can't. And I will spend a lot of time in class, in lab, and running around the building. So it's probably better to try the mobile. But interestingly, the mobile doesn't work in my office. So I can usually get a text, but sometimes the calls don't go through. So you can try both numbers, but like I say, send me a text first, and then you can try both numbers. But probably the best thing to do is to email me. All right. With respect to email, I don't there's email that's associated with the Blackboard system. You can message me on Blackboard, but I generally never check that. I don't even know how to check that for sure. So try not to, don't use the Blackboard email system. Just go ahead and use paul.morton@utsa.edu. That's easy to remember. And as long as you remember my name, you can crank that out. And I do look at that email. I try and stay up with it. I may get behind over the weekend. So if you email me late on Friday, I may not respond until Tuesday morning because it may be Monday sometime before I actually see it. But on weekdays, I do try and check it. So, and if it's a real emergency, then send me a text and we can talk on the cell phone. Okay, so I did a little bio about myself. I don't know, I know the word gets around. So most of the time people have some inkling of various professors. I have an MD, a medical doctorate. I also have a PhD in electrical engineering. I did my undergraduate work at Purdue. I did all my graduate work at the University of Missouri, both my master's, my PhD, and my MD. Although I did my first 2 years of medical school at St. Louis U, and then I came back to Missouri to finish the PhD and the MD. I actually finished my MD in June of 1981, and I got my PhD in December of that same year. I actually wrote it up as an intern at Washington University Barnes Hospital, which was a busy time. But it took 1 week of vacation to get it typed up and 1 week of vacation to defend my thesis. And that left me 1 week to actually vacation from my internship, which was back in the days when we didn't have any restrictions on hours. So it was like probably 100 hours a week kind of stuff. But anyway, I then halfway through residency stayed where I was, but I switched from getting paid by WashU to getting paid by the Air Force. And then I owed the Air Force 2 years, and I went out to a small base in California and delivered babies and worked about 120 hours a week, if you can believe that, leaving almost no time for sleep and certainly no time for anything else. And it was pretty stressful, but I actually enjoyed it mostly. Anyway, I finished that 2 years, was going to get out of the Air Force and go back to WashU because they have an electrical engineering department and they have one of the top ranked medical schools in the whole country. And so I thought I'd do that. But instead, I wound up going to Wright-Patterson Air Force Base and went to the Air Medical Research Lab, which was kind of cool because I could do engineering 3 days a week, and I go over to the med center and do medicine 2 days a week. One day a week, I would see patients and do urodynamics, and the other day I'd operate with the residents. And actually, that was very enjoyable. And then once or twice a year, I'd deploy with the test wing all around the world. I had actually, when I finished at Purdue, I was on a ROTC. Well, I wasn't on an ROTC scholarship, but I was in ROTC. So I was commissioned as second lieutenant, went off to infantry officer basic, then went to flight school for about a year, and then did and then I went to airborne and then Ranger school, and then went to Vietnam and flew helicopters for most of my time in Vietnam, but for a good part of it, I also worked as an infantry officer. Had some interesting and exciting times. Came back, did 10 months at Fort Leonard Wood, and then got out and went to the University of Missouri. And I spent a year thinking about doing full-time Christian work, but instead I wound up after that year going back to school full-time, and that's when I got my master's, MD, and PhD. All right. So in the Air Force, I practiced medicine, engineering and medicine at Wright-Pat for 9 years, and then I came down to came down to San Antonio, and I became the chairman of the OB-GYN department. Wilford Hall combined with Brooke Army Medical Center, now San Antonio Military Medical Center, or whatever it is, SAMC. And anyway, I did that for 9 years and got out, did private practice for 9 years. While I was still department chair at BAMC, the chairman of the OB-GYN department, of the electrical engineering department, called me up and asked me if I wanted to teach logic design. And I told him, yeah, actually, I'd be interested in doing that. so I started teaching logic design when I was still on active duty. And then then when I went into private practice, I missed a year, I think, or so, and then started teaching again, and continue to do that pretty much ever since 2001 until the present time, with about 3 semesters I think I didn't teach, somewhere in there. I certainly enjoyed it, and they asked me if I could teach a little more, and I said, well, I took on one more course, but I was teaching 2 courses, which is really it's more than half time, really. I was doing my own private OBGYN practice, and I was the director of a weight loss clinic, medical director of a weight loss clinic. And so I was working like a dog, and they wanted me to do more. And I said, well, when I close my practice, I'll do more. And finally in 2013, I closed my practice, and then they created a full-time position for me at UTSA. And so that's where I've been ever since. I did keep seeing patients once a month until about 2 years ago. And I still have my license, but I'm not really doing much in the way of active clinical practice anymore. Okay, so that's kind of my background. I've been married for 45 years, working on 46, have 3 daughters, all of whom are married, and the youngest one's getting ready to have her first baby, and that'll make us 9 grandchildren, assuming that goes well. We do a ministry at church with married folks that are having struggles. We also we have another ministry where we mentor married medical and dental students to try and keep them married while they're in the stress of medical and dental school. And now we have a bunch of residents in that same little ministry. So I'm also going through a program called Celebrate Recovery, and doing a step study in that program. And I'm also a leader in Bible Study Fellowship. So I'm involved in a lot of Christian activities, but I don't talk about that in class, because in class we talk about engineering. But if you want to talk to me about it anytime, the door is always open. I consider my job is to inspire you to be really hungry to learn about microprocessors, about logic design, about digital systems design, and the various hardware description languages, and embedded design. And logic design is the foundational information for all that. You really have to understand logic design in order to really have confidence to work in those fields. And so this is a really important foundational course. Interestingly, when I was at Purdue, we didn't have logic design. Wasn't a course, wasn't offered, nobody took it because it didn't exist. And that was because we didn't have much in the way of digital electronics. We did have computers. They had a lot of vacuum tubes in them and some transistors, but transistors are kind of a new thing. They've been around for a few years, but since the early 50s. But in the 60s, we still hadn't really developed integrated circuits. They really didn't exist until kind of late 60s or mid 60s at the earliest. And they were a pretty new thing. They were just a simple 4-input AND gate in an integrated circuit could cost you $1,000. So it wasn't a common thing at all. But of course, that's all changed. Now, almost everything is digital that can possibly be made digital. And we only do a little bit of analog. And we're going to talk about the difference between analog and digital and the definitions here in just a minute. So anyway, so you can read a little bit about my bio and my teaching philosophy. But I think that I sort of take it for granted that most of you are excited about engineering. If you're not, you should do a different major. And if you're excited about engineering, then this is knowledge you really need to get. And a lot of students look back and see this as one of the more enjoyable courses they took. So anyway, here's the way the course works. It's a 3-hour lecture course, 1-hour recitation. There's no lab. There is a lab associated with it, but it's a separate course taught by Dr. Patrick Benavides. And Patrick's a great guy, and it's EE 2511. Logic Design Laboratory. And most of you are taking that or have taken it or will take it. And it's, we're still sort of, I'm talking to Patrick and we're trying to sort of modify it to sort of sync it a little better with this course. We'll see how we do with that. But hopefully we'll finally get there. All right. So again, the textbook is Logic Design. The published date's 2020, but actually we didn't finish it. Well, it's still being polished up. So it's it's hot off the press, and it's a web-based book. And I'll show you what that looks like. It is. Let's see, did it drop off? Yeah, it did. So this is what it looks like when it comes up. This is chapter 1. And then if you click up here, it gives you all the chapters. There are 18 chapters. And there's an appendix. And that's the problems. I'll probably do another appendix on Quine and McCluskey because I've agonized over whether or not it's important for you to know anything about Quine and McCluskey. And I finally thought, okay, I'll put it in as appendix because, I don't know. I guess you ought to have heard about it. And I might even have you, I don't know. Traditionally, I've taught it and I've even given a quiz on it, but I've tried to keep it off the test because it's time consuming and tedious. I don't know. I think I'll make it as an appendix and I may just have a few questions about it and really not spend a whole lot of time on it because I don't think it's that important. And anyway, we're going to cover basically how come digital electronics has taken over everything? Why do we not use analog much anymore? And then we'll move from that to the number systems. Basically, there are 3 number systems that we really pay attention to. Of course, decimal, which is what you've been using your whole life till now. Obviously, binary, because that's pretty much still how computers are organized. And then hex, because hex has some real convenience for us. And so we use hex. We don't really use any other bases. So it's base 10, base 16, and base 2. Those are the only ones we're really interested in. The rest of them are curiosities at this point. Then we'll talk a little bit about how our 2-valued world, where things are just true or false, ones or zeros, how that binary world, how that works and how we use that, and how we have a whole bunch of gates that allow us to make essentially all our digital devices. And then we'll talk about switching algebra in chapter 4. Basically, there's about 15 theorems that make up switching algebra. And that defines everything you can do in switching algebra, and that's all you can do. And we'll cover those and hopefully give you a little bit of a foundation in switching algebra, and hopefully you can exercise your muscles in that a little bit. But like I say, you don't have to become an expert. I just want you to have slightly more than a level of familiarity. I want you to have a little bit of practical experience working out problems. Then we're going to start dealing with truth tables, which for our combinational designs is our gold standard source document that we base all the design on. We'll talk about how we can simplify those with K-maps. We'll talk about, well, once we get to this point, we'll be ready to do our first test. Then we'll get into K-maps. We'll get into some of the more advanced issues in combinational design. We'll talk about the basics, the standard models, and then we'll look at some combinational devices that we use frequently in the digital world, things like multiplexers, decoders, read-only memories, things like that, adders. And then we'll talk about how we can use computer-based hardware description languages to design our digital circuits. Just to give you an example, I was just looked up the latest one of the latest NVIDIA chips. So they currently make a chip that has two instantiations of this fundamental chip. So it's just 2 copies of the same chip on one piece of silicon, essentially. And it has something like 14 billion transistors on that chip. 14 billion transistors. Now, just so you can get a picture of why we don't sit down with on a drawing board with a schematic and and a T-square and a pencil and draw the circuit. If you used 1 square inch to design for each transistor, and you had 14 billion of them in your schematic, your piece of paper would have to be many square miles in size, something like 20 square miles, which of course is ludicrous. I mean, you could never have a piece of paper 20 square miles in size because it doesn't exist, can't be made. There's no way to do that. And not only that, but if you had one, where would you roll it out? You'd have to have one of the big ranches like the what is the big ranch down south?
The King Ranch?
Yeah, you'd have to have the King Ranch to roll out your schematic. Exactly. And you'd have to have a little helicopter with a sling to fly you around over it so that you could look at it. And how long would it take a human to draw that? A schematic, say 20 square miles in size. How would you, could you even draw it in an entire lifetime? I don't think so.
It would be quite an accomplishment.
It would be, yeah, it would just be unbelievable. 20 square miles, 1 square inch at a time. If you did the math, let's say you could draw each transistor you could draw in at about, say a minute. So how many minutes is 14 billion minutes? I don't know, somebody can do the math. Probably more than your lifetime. So in fact, it's probably many lifetimes. So you can see, we simply can't do business the way we used to do it. You can't sit down and draw a schematic for the circuit that you want to put on a chip now. Can't do it. Even a modest chip's going to have millions of transistors on it. So, I mean, even then you're talking a schematic way bigger than a neighborhood in San Antonio. So we have to use other tools, and the tools we use for that are basically our hardware description language tools. And in order to use those tools, you have to understand everything that you're going to learn in logic design. It's the foundation for that. All right. So anyway, we'll talk about that. And we'll also talk about that in context of not just the hardware description language, but we'll also talk about it in context of C++ programming language. All right. So then we'll talk about flip-flops, which are basically our fundamental sort of memory device, if you will. We'll talk about how we use feedback to get memory, and how we have a flip-flop that makes all the registers in all our computers. It's the highest speed memory we have, and we'll talk about how we do that with flip-flops. And then we'll talk about how we use flip-flops and combinational blocks of logic to create sequential designs. And so then we'll go through a bunch of the principles of sequential designs, and then we'll talk about how we use our hardware description languages, not just with combinational design, but also with sequential design. We'll learn about using state machine charts and how we can do sequential designs with state machine charts. And then we'll talk about how do you develop an algorithm to get something done, and how do you put this all together when you want to create a system design. So anyway, so that's kind of how the text is laid out. And so go ahead and read the first chapter, and then you can do the quiz at the end of the first chapter. Every chapter has a quiz at the end, or sort of a little mini test. And once you do that test, then it records your score. And I'm probably going to treat the test at the end of each chapter essentially like your homework. That's my initial plan. And we'll see if that seems to be sufficient. And if it's not, then we'll do something else. We may add some homework. I may add an occasional homework additional assignment, but I think that's my going in plan is to use that basically as the homework. Okay. All right. That's enough of that. And then if you go on down, you can see that there's information on the grading scheme in the syllabus. So they're going to be, I don't know if I'm probably not going to use the lecture quizzes. So I'm going to leave on Blackboard, on your Blackboard. I haven't populated it yet. I'll do that. But I'll put on your Blackboard all the videos that I used in the other course. It's parallel to what we're doing, but it doesn't follow the text exactly, and it won't follow my lectures exactly, but it'll be similar. So if you want to look, if you have, you can find a topic in there you want to, see another lecture on, you can watch that video if you want. We will do a group project, and it's going to count 6 course points out of 100. I probably won't do attendance unless it's, unless attendance is really bad, and then I might start taking attendance. If I do that, I'll use the no cost. Oh, I forget the system it is, but anyway, I'll do the no cost. Yeah, I forget. Anyway, I'll talk about that if I decide to do that. And then the homework at the end of the chapters will count maybe as much as 20 points. We'll see. And then we'll have 2 midterm exams that will count 35 points and a final exam that counts 30 points. So that's sort of how the grades will be. Again, I probably won't do these lecture quizzes. So there'll be 5 points I'll have to divide up between all these to get to 100. And I usually just do, I do A, B, C, D, F. So the range for A minus and B plus will be 0, and B minus and C plus will be very small, almost 0, and so forth. If this is a course, if you do the work, you can get an A you can definitely do that. If you just give it a pretty good effort, you should be able to get a B. If you goof off and don't do the work, you probably get a C. I do put a fair amount of stock in, doing the quizzes at the end of each chapter, doing the group project, and doing a good job on that. And if you do those things, that'll help you a lot. If you really bomb a test, don't worry. I usually let you do corrections and make it and get it up to at least a 70. So I don't want anybody to bomb a test and feel like they killed their grade. That's not the case. You can still get a B even if you bomb the test completely. All you got to do is just pick it up on the next couple of tests a little bit. You don't have to get hundreds. Is there a question?
Yes, I have a question. Will the quizzes on the lectures, those are separate from the chapter quizzes, correct?
Yeah, this is actually more for the other course. I'm not going to do that for you guys.
Okay.
So I probably should just cross this out, actually. I will just delete that, and I'll divide those points up. So I'll fix that. Yeah.
And you said that the maximum amount for corrections on exam is 70, right?
Yeah, if you really bolo it, then yeah, 70 is usually. Sometimes I'll let people with a kind of a marginal call maybe get a few extra points if they do corrections too. So if you get a 69, maybe I'll give you 3 more points or something. If you get a 70 and you want to do corrections, you can get a 73. So something like that. So again, if you bomb a test, don't panic. And the other thing is, if you're struggling, come in and see me. Don't just don't spin down into a failure mode. Everybody can pass this course. Anybody that's done calculus has enough smarts to get an A in this course. So if you don't get an A in this course, it's well, if you really if you do kind of crappy on the test, you still can get a B. If you just do reasonable. And for sure, you can get a C if you just do the work. Nobody's gonna get less than a C if they do the work. People that flunk don't turn in any homework, and in your case, don't do the quizzes, the tests at the end of the chapters, and don't come to class and don't do corrections on their tests, and maybe don't even take the stupid final. As a result, they flunk. But that shouldn't happen. And again, there's be some couple of opportunities to get some extra credit. So just so feel free to this is a course you can do well in. You just have to stay up. The problem in this course is if you get behind and you get lost, you can't guess your way through. You have to know what you're doing. It's just no substitute. Answers in a digital system are very determinative. It's either right or it's completely wrong. There's no middle ground. It's not almost right. So, all right. And I think that's basically mostly. At the very end of the quiz, at the syllabus, there's a schedule, and it lays out pretty much every week what we're going to cover. And so basically, you can see every day kind of what I'm recommending you read. There's a read and do for every day. Because it's an in-person, we don't have videos, but the videos will still be on Blackboard. You can look at them if you want. It says when the homework is due, but I think at this point you can ignore that because I hadn't really decided for sure what I was going to do, but I think I'm going to set it up so that you just have to do the quiz at the end of the chapter, and so I'll make that clear. Yeah, so here it is, end of chapter quiz, okay, and so that's what you have to do, and the homework one, I'll probably go through and take this out of the syllabus because I'm not 100% certain, but at this point, there's no homework assigned other than the test at the end of the chapter. So I may add some back in, so I don't know. I may just gray this out and then we'll see what happens. If I see everybody's progressing well and learning the material, I'm going to be cool. If I feel like people are really struggling, I may feel like you need some more work to do. So we'll see. So it'll be in your interest to stay up and, you know, do the readings, do the tests, show up in class. And when I ask questions and people give good answers, I'm going to feel good. When people start don't know what's going on, I'm going to feel like I might need to motivate you along a little bit. So,
Professor, I got a question.
Yeah.
I was trying to access the syllabus on the Blackboard or whatever, but I wasn't able.
it's not on Blackboard. It is on Blue Book if you want to pull it up. I don't know if
Blue
you
Book,
ever.
I don't know what Blue Book is. I'm sorry.
Yeah, that's okay. Don't worry. It's some kind of university requirement thing, but I will put it on. I'll put it on Blackboard today. It'll be over there today.
Okay, perfect.
I'll pop it over and get it updated today. I will do that. I kind of been waiting because I wanted to finish. I don't know. I've been kind of agonizing over the homework thing. All right. Okay, let me switch off. So if you go through this, you can, and like I say, yeah, you don't have access to it right now, except through Blue Book, which most of you never looked at, and that's fine. Don't bother. I'll put it on Blackboard today. Okay, so I'm gonna shut that down, and then, okay. Then what I wanted to do was PowerPoint. Okay, so let me. Okay, can you all see that okay?
Yes.
Okay, so we kind of gone through the syllabus a little bit. I talked about the text. We will do group projects. I'll talk a lot more about that as time goes on. I'd like you to finish the group projects before we take the second midterm. So so it'll be after the first midterm. We'll get started on those in earnest. And I want them all done by the second midterm. The group projects are going to be new. They're going to be based on a 17 segment display instead of a 7 segment display. And I haven't used these before, so there may be some growing pains. We'll see. The projects I did before were all in the Roth book, so I had to come up with a bunch, and they're in the appendix. And they're basically all very similar. You just these 17 segment displays. Let's see if I can. Let me find a quick picture for that. Let's see. Let's see if I can find. Yeah. Okay. Let's see if this comes up. No, that's 7 segment. So don't know. This is it. No, I don't think this. This may be it. Let's see. No, okay. Yeah, okay, well, maybe let me do eBay. Yeah, I'll just show it to you. I should have had a picture all pulled up. So these are 7 segment displays, all 7 segment displays. But we will eventually see one here. Yeah, they call them in here, they call them 14 segment, but it's the same idea. So I don't know if you can see that very. So you can see that these are double digit ones. You can see they have, 1, 2, 3, 4, 5, 6 segments around the sides. And then they have 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, I guess that is 16. So anyway, so this is what it'll be, except we'll just use a single one, not a double one. And this is kind of, so what's nice about this is you can show all sorts of letters and characters with it. It can display lots of different things. And so that's how the things will be displayed. If we go to the appendix, I can't remember if I put that in there. I think maybe I did. See. Yeah, so here's the display. Oh, yeah. It does have, so the difference is this one has the top bar split in half and the bottom bar split in half, whereas the one we just looked at didn't. So this is a true, this has 1, 2, 3, 4, 5, 6, 7, 8, and then 9, 10, 11, 12, 13, 14, 15, 16, plus the decimal point 17. And you can see here all the things that it can show. Just all the letters, all the capital letters, all the lowercase letters, all the numbers, brackets, curly brackets, punctuation, all sorts of stuff. And so basically an example would be display the capital letter, right? So you have to write a set of gates that will display, say, A, B, C, D, E, F, G, H, I, J, using the 14 segment hex display with 4 inputs. And there'll be some don't cares and other stuff. And by the time you get to this, you'll be able to do this. So it'll be kind of fun. And each one, this one has 8 more letters, and then this has some random letters, or yeah. So anyway, so they're all different, and I think there's 26 different ones. All right. Okay, so hopefully after 3 weeks, we're going to be face-to-face in class. It'll be 11 to 11:50, and we're right at the end of time today, so I'm going to quit. I probably will do some new videos. I'll post this video, but I'm going to leave up the old videos that are synced up to the Roth book. But you can look at the little captions and see basically what they talk about, and you can look at them if they're helpful. You're welcome to use those. All right. Yeah. Let's see. So I did want to say a couple more things, and then I'll quit. So the course is really 3 functional parts. It is an intro. The first part is kind of the intro, switching algebra, the definition of digital and analog, and introduction to switching algebra and binary numbers. And then we're going to do the combinational design part, and then we're going to do the sequential design part. So there are 3 big parts, kind of the switching algebra and number system part, and then how to do combinational designs, and then how to take those combinational designs and add a clock and some memory and create sequential designs. That's the 3 parts. we're gonna talk about a complex concepts of how to manage complexity. If you think about a schematic, 20 square miles in size, you should, the next thought in your brain should be, that's pretty complex. And indeed it is. How do we actually manufacture something like that in quantity fairly inexpensively? And the only way we can do that is to use some tools to manage complexity. And we'll talk about what those tools are. And that includes layers of abstraction. And when you do your project, hopefully a lot of it will make sense. So I think I'm going to stop with this. Let me just we'll take a little minute and give you all a chance to ask any more questions. And then we'll pick up here on Wednesday. So what questions do you all have?
Until-
I do have a question just about the recitation. Will we have one this week?
So I haven't, I had an email from the TA. He just got assigned Friday. So probably no recitation this week. But hopefully he'll get it together and have one on Zoom the week after and the week after. And then maybe on Zoom, maybe in person, whatever you all want to do is fine with me. Whatever he wants to do is fine. If you all want it in person, then I'll lean on him to do it in person. If you all don't care, then he can do whatever he wants to do. So just let me, if somebody has strong feelings, let me know.
Thank you.
Okay, and the textbook, sir, how would you get it? Does it have a link or?
Yeah, so the bookstore had some, and they were actually a little cheaper in the bookstore, believe it or not, because the bookstore was actually made them available at their cost. Interestingly enough, I don't know if that was a mistake or not. So the bookstore has some, and then you can always go on the web to Great River Learning. Let's see. Let me see if I can pull that up.
Do you guys have partnership with Chegg or no?
What's that?
You guys have partnership with Chegg or no?
So Chegg always goes in and basically, every problem set that's ever been done, Chegg eventually gets solutions to it because students will, log on and upload the solutions. This probably won't have anything on Chegg initially, but it will probably get populated eventually. But just because it's brand new. So let me see if I can pull up River Learning. I may have to send out an email to the whole class to tell you how to get the textbook. Let's see. Let me pull up Great River Learning. Alerts, announcement, calendar. No. Okay. I don't have a good answer right off the top of my head. I will send out an email hopefully today to let you know how to get it from Great River Learning. And of course you can always do the bookstore. I don't know how many the bookstore bought. I don't think it was too many. And their at cost price will probably go up when they realize that they're not making any money on it. So I don't know.
Is it the UTSA bookstore, right?
Yeah, it's at the bookstore. I think it's 70 something. If you do it on the website, I think the cost of the book is $85. That's the cost. So, which I don't know. I don't have any control over that. Like I say, I don't make any money on it. I think I make $8 and change each copy, which I'm not even going to see. It's going to go straight to the university into the scholarship fund. They filled out the W-2. I didn't even fill out the W-2, so I won't ever see the money, which is fine. It's not for me. It was not about the money, but if I had it to do over, I might. I don't know. I might have just done it myself and published myself and made it really cheap for students because I don't know. I learned a lot doing this. Learned a lot about publishing companies. Learned a lot about how they how they're sort of how they market. It's interesting, and there's a lot of things I didn't think to ask until way late in the process. one of the things I did say, if you buy the book and you drop the course and then you take it next semester, you don't have to buy the book again. You can if you drop the course and take it again, your one-time fee will cover your use of the book for the next course if you take it again. Once you finish the course, I'll probably have them, I talked to them about having you have access for a while. I don't think you'll really need it to go back and refer to it, frankly. But I'll probably have you, I talked about just leaving it available to you for a year, even after the course. So in case you did want to refer to it, you could. And I think they were okay with that. They didn't have a gigantic problem with that. But you can't, I asked them, can they sell it to other students? No, you can't do that. And they kind of use the test at the end of each chapter is sort of part of their hook, to kind of get students to buy the book, which I also didn't appreciate until we were about done with it. Anyway, there were a lot of interesting things. We also had to include features for blind students and things like that, but probably nobody on here is blind. So it's kind of interesting. But the nice thing is if it gets adopted at other universities, they'll be funding the scholarship here. So that'll be great. Anyway, so hopefully that's what'll happen eventually. We'll see. And they make no commitments about marketing it. It's kind of interesting, really kind of interesting. But like I said, I learned a lot about publishing companies. It kind of works out that the professor does all the work and they make all the money. So just what it is. All right. I want to let you guys go. So feel free to shoot me emails if you have any questions. And I'm really looking forward to seeing you face to face. And I think you guys are going to enjoy this course. And if you just kind of hang in there and give it a reasonable level of effort consistently through the semester, you'll do fine. Just don't panic in some other course and stop doing your logic design and get behind. Once you get behind, it's really hard to catch up. So don't do that. All right. We'll see you guys later. See you on Wednesday.
Bye.
Thank you, Professor.
You bet. Bye-bye, guys.
Thank you.